Ed Kileff, welcome to the show.
Thank you.
So, for the benefit of the listener, Ed and I both work for CR Plus. They're a consultancy supporting industry, decarbonising, cost saving, energy efficiency, and also doing a lot of funding support as well. But Ed has a specialist expertise in high temperature heat pumps, and we're going to talk a little bit about that today. So, thank you for coming on, Ed. I really appreciate your time. But if we start off at a super high level, what is a high temperature heat pump?
Well, I'm glad you asked. What I'm going to do is start with what a heat pump is before I then differentiate and tell you what a high temperature heat pump is. And it's sort of worth saying, I mean, although I've got a special interest in heat pumps, that's not all I do. The reason why I focus on it so much is I can see how much value there is and untapped value in industry. And that's why I'm so enthusiastic about this sort of technology. Um, but essentially, a heat pump is something that increases the grade of heat. There's lots of different types, but the most common really is something that uses an electrically driven compressor, and essentially it takes in waste heat, ambient heat, anything. It boils a gas and you use the compressor to squash the gas, and that increases the temperature of that gas to a useful grade. And the magic thing about them is you can put a very little amount of energy in and get a lot out. And that's why it's such a crucial technology for industry. You might hear me talk about something called a coefficient of performance. I mean, a lot of the viewers may know what that is, but essentially it is a number that tells you for how much electricity you're putting into the system, how much heat you're getting out. And when we're looking at particularly industry or homes or anything like that, electricity is a lot more expensive than gas or fossil fuels. So what we're looking for is that coefficient of performance to be even better than that price gap, so we can actually make the heat cheaper and renewable, which is why it's such an important technology. Onto high temperature heat pumps. So heat pumps have been around for a long time. High temperatures are not novel in an idea, but the amount of technology and the investment going in is a little bit more new, and it's more typically applied to industrial scale applications. And there's a lot of arguments over what's considered a high temperature heat pump, but typically we're talking about anything that can go over 100 degrees, 100 degrees Celsius. There's For decades, you've been able to access heat pumps up to sort of 70 degrees. Some of the more common applications for industry are pushing up to 80, 90 degrees if you're looking at the ammonia systems and some of the hydrocarbon and HFO systems. But essentially, we kind of need that next step change to get over 100 degrees and make it efficient. Why that's really important is because there's a whole new suite of market applications for that. So when we're talking about, steam, drying processes, chemical processes, um, between 100 and 200 degrees, you're almost tripling the amount of applications you can get for these sorts of systems. So I think one figure I've got in my head is 26% of all industrial energy in Europe is between the 120 200 degree mark. So you can see just
Wow.
how valuable if we can get systems that can cost effectively generate heat at those sorts of temperatures, then you're onto a winner. The last thing I would say is that they're usually in the hundreds of kilowatts to megawatts, tens of megawatts phase. So typically, you're not seeing many in the sort of tens of kilowatts. They're not the industrial sort of heat pumps in terms of where they're most cost efficient is sort of the larger scale applications. But that's really what's needed, and that's where the demand is.
Just to ask you a question about the coefficient of performance. I assume that's kind of like an efficiency reading. What kind of coefficient of performance are typical in terms of the energy in versus the heat out that you get?
Well, that's the golden question. That can vary completely depending on the technology you're getting, the
Got you.
temperature lifts.
Got you.
So when we're looking at systems, we tend first and foremost to look at how much temperature you're trying to lift, the availability of waste heat, and if you're lifting 100 degrees, a coefficient of performance of
Mm.
three is completely possible, even a little bit higher in some instances. But
Wow.
at the same time, you can buy systems that will do that for less than two. It really depends on what you're buying and what the use case is.
Got you.
Yeah.
Got you. So we've kind of looked at what a heat pump is, what a high temperature heat pump is, and how they kind of work in simple terms. But why are they needed? Why should people bother? Is it just an opportunity vehicle that you can use to get these higher efficiencies or coefficient of performances
hmm
specific to your process, or are there other reasons that you might want to use them as well?
Well, I think there's a couple of things really. One is the decarbonisation driver for industry, and one is the cost driver. So if we just start with the decarbonisation um, sort of driver, so there's a lot of supply chain, government regulation sort of pressure to decarbonize process. So a lot of these industries simply won't exist in 20, 30 years time if they don't do something about their emissions. But the real question is, how do they do that in a cost effective and competitive way? So the thing they should be thinking about is, to the second point, is the cost, is how do I ensure my operation is as low cost and as competitive as possible, so I can deliver my goods at the highest margins and the best value to my customers. And this is where typically you're seeing high temperature heat pumps being, uh, there's never a silver bullet, but as close as it can be as a silver bullet to steam applications, and other sort of 100 to 200 degree applications in industry. In some cases, we're seeing them, the economics of them actually surpassing the value of operating CHPs, which have been the industry norm for 40 years.
Wow.
So really, if you want a competitive operation and these are the right sort of technologies for your process, then you really should be considering them for your next sort of investment round.
Yeah. Well, that leads us into our next question wonderfully, really. So you said if the technology is right for your site and if you want to be competitive, what are the processes that are really good candidates for high temperature heat processes, high temperature heat pumps? Said that a couple of
hmm
times today. High temperature heat pumps to really make that a cost competitive transition.
Yeah. So I'll start with the industries. I think because there's all sorts of processes that are relevant to this, but the
Yeah.
the real three big hitters in industry are the food sector, the paper sector, and the chemical sector. Because that's where a lot of the heat demand is in industry, the scale, but also the right grades and profiles of heat to actually get the most value out of these systems. So I mean, I'll give you a few examples. So the food industry are probably closer to the mark with this because many of the operations already run refrigeration processes, and it's pretty similar technology. They've operated day in day out. A refrigeration compressor is just a heat pump compressor, but packaged up with a different title, and instead of the cold side, that's the hot side that's valuable. A couple of examples. An organization in Norway called Neo Industry has built an ammonia steam system a few years back that basically upgrades very low grade waste heat, maybe 20, 30 degrees, up to 120 to 140 degree steam at 2 megawatt. And that's used for a drying process for animal feed. Really efficient system. You're talking about a coefficient of performance of about 3 there, and that's enough to get
Oh wow.
quite a reasonable payback on that process, particularly if you're looking at the energy prices in Scandinavia. Um, There's been a couple of programs, particularly on Horizon Europe lately. So GA, very very profound, well-known company that produces refrigeration and heat pump systems, has developed a system for a sugar processing facility. That's delivering, I believe it's about 140 degrees using a hydrocarbon refrigerant. A couple of other examples. So breweries, when you're making beer, you've got to get those nice sort of flavors, and so you're throwing your hops into a work kettle, and you're boiling it off. So uh, a UK company called Future Heat has installed a system. I think it's a 300 kilowatt system at Hepworth Brewery in Sussex, and essentially capturing the waste vapors off the stack, and putting it back in as steam, the heat back in as steam. So it's essentially recycling the heat around the system really efficiently.
Mm.
So, I mean, that's the food sector. One advantage of that sector really is, if you've got existing refrigeration processes or lots of waste heat available, you can tap directly into those. So you're not having to build the entire system from scratch. It's kind of a bit of a retrofit, and you can get a better sort of payback, because of the lower capex on that side. Paper industry, seeing a lot of interest. The Confederation of European Paper Industries has really sort of doubled down on understanding and engaging with the industry throughout Europe on what technology is available, what the industry needs, and what is feasible for the industry. So we're seeing a bunch of initiatives sort of taking off, and I think to date, off the top of my head, there's about 6 different industrial applications. A lot of them are prototype sort of examples, but some are getting more towards full scale deployment applications. If you're interested, there's a couple of initiatives I'd suggest you look at. As Push to Heat, it's a Horizon funded initiative, and the Spirit Heat project, which is another Horizon project that is looking at essentially what we'll be installing applications in the paper, food, and chemical industry. So they're really good examples if you're interested. And in terms of chemicals, the last big application, BASF have just announced a 300 megawatt, that is about 300 million euro investment in one of their processes in Germany for the production of formic acid. So that will be the most powerful heat pump in the world, and that will be delivering steam in about 2027. So yeah, you can see
Wow.
there's a lot of sort of investment, a lot going on
Yeah.
at the moment.
Yeah.
Yeah.
So that's a common theme that you see in big innovations, and also a lot of funding and investment going in. And I guess that's one of the reasons why it makes you so excited to be involved in this space and interested in this space. Would you say?
Yeah, I'd say so. I'd say that there's a new industry budding here. It's ready to explode
Mm.
in a good way. So, um, so I think the understanding of what's out there in industry, and even in the heat pump sector, is still forming, but there is a lot, and you just have to dig a little bit to find what you need. I mean, I mentioned food, paper, and chemicals as core sectors, but we're seeing other applications in waste processing, brick drying, starch drying, uh, production of any sort of steam application. We're seeing a lot of technologies stepping up to the mark to be able to deliver that, but also use cases actually becoming quite commonplace. But it's still early days. You're not going to walk into every factory and find one of these things, but I suspect in 5-10 years time that will be the norm.
Bro. So um, it all sounds kind of perfect, to be honest. You said it's not quite a silver bullet, but there's that saying, isn't there, that you don't want a silver bullet, you want 100 golden BBs where you can just have all these different options. So
I've not heard
if
that
it's
one
if
before.
it's not quite a if it's not a silver bullet, what are maybe the reasons why it's not on every shop floor
Hmm.
so far? What needs to happen to get us there? If that is going to be the solution that really drives a huge push in net zero.
Hmm. So I think there are quite a few hurdles to jump before it's really an established method of changing your operation, fuel switching, or decarbonizing. One is essentially the maturity of some of the technologies. So, as I mentioned, sort of there are prototypes out there. There are a handful of use cases where there are standard products, but what you're not seeing is hundreds of these things rolled out. And particularly capital intensive industries are quite cautious about spending a lot of money on something that they need for 20 years, but they've not had a 20-year use case to
Yeah.
prove that. So you can see the hesitation of doing that. Also, if you're operating a gas-fired boiler, you turn on a flame and steam comes out one end. It's quite a simple process. These systems
Mm,
can be quite abstract, and the integration of them has to be done carefully and requires quite a lot of knowledge and expertise. So you can see there's a bit of a gap between, well, we want to buy one of these things and then designing it and then installing it, and then a whole bunch of unknowns and costs involved with that, which does sort of constrict at the time. But I think that will diminish over time as some of the use cases come in and some of the standards in terms of standard retrofit solutions, and how you actually go about retrofitting reliably and cost effectively, making sure that when you plug it in and turn it on, it's going to do its job. Um,
mm.
I think it's a matter of time, and as the industry sort of matures and the use cases uh, become a lot more established, then that's when we'll see the big switch.
Well, so more mature, established, uh, in the public eye, maybe. So people may see it, and once they've seen someone else do it, they may have a bit more confidence to be the second person in the door, let's say.
Hmm.
What are some other misconceptions that maybe put people off even thinking about high temperature heat pumps? What are some kind of reasons that they say our process can't do that because XYZ? What are
Hmm.
some examples there?
So I think I'll break it down into three different things. So one is the technology maturity, which I've just mentioned, but I'll come on to why that's not always the case. Reliability is obviously one that needs to be addressed, and again, it's not always the case. You can buy some pretty standard reliable kit today, and then
Mm,
also the cost and where that fits. So, if I just start with the technology maturity, it's true there are a lot of systems, very promising technologies being sort of developed and on the stage, but um, we've been able to buy steam compressors, particularly for decades. Mechanical vapor recompression processes are an example of that, and they use very standard kit. I think I've come across examples where one compressor without really very much maintenance at all has been operating for 40 years and never really had a problem. These
wow.
things do exist, and particularly for small temperature lifts, you can get coefficients of performance up to 10 or beyond in some cases. I think in terms of reliability, I've heard a lot of commentary on and comparison between domestic cases. So these sort of air source heat pumps or ground source heat pumps that are not heating up homes as well as they should do, and they're breaking, are totally different things to the industrial heat pump industry. So it's not apples and apples, should I say, to compare the two. A lot of the industrial applications are really well established compressor technologies that are being adapted for high temperatures or different working refrigerants, and they are sort of proven concepts and proven technologies that will operate and will operate reliably. And the last thing is cost. I've also heard they're too expensive. I think it's quite a flippant sort of remark you get, and whilst that can be true, in a lot of cases, what you're not seeing is the right technologies being attracted to the right applications. It's very much horses for courses. If you've got a process that requires a relatively low grade of steam and you've got high volume, you don't want to be putting loads of piston compressors in to develop the steam for that. You probably want a more high volume, low lift compressor and a lot fewer of them. So it's really understanding the technology, what's available, and what the right applications are, because you can really take a load of cost out by choosing the right stuff, and also a lot of cost in operating the equipment, because efficiency is a big thing as well.
Bro. So you mentioned a few things there. So you mentioned kind of these perceptions can be shattered once the first person's through the door and kind of using it. Are there any examples that you can give?
Mm-hmm. So I did mention some applications in the paper, chemical, and food industries earlier. I'd say the earlier sort of research projects that sort of called dry efficiency, which started in 2016, developed three different heat pump solutions. Two of the applications have actually developed into commercial organizations, and they're selling standard compressors and are being used in multiple industries. So I'd say have a look at the Spirit and Push to Heat projects as well, because what you've got in there is industry players that have delivered actual solutions in the food sector predominantly. One other interesting application is that there's a carbon capture process that's being run on a system. It's a Stirling cycle helium heat pump developed by Enerin. And that system can deliver up to 250 degrees on the hot end. So that is operating and it is running, and there are additional applications of that in industry as well. So there are plenty of examples. Where I'd say that there are a lot of commonplace applications are some of the more centrifugal compressor systems, so in steam vapor recompression technologies. So there's rubber processes, petrochemical processes, and evaporation processes that are using, should I say, centrifugal fans to compress steam and generate steam up to 200 degrees, and those are pretty well established as well.
Cool. Yeah, no, that's perfect. Thank you. So at the end, we've just spoken purely about technical things, really, so far. Towards the end of this discussion, I'd like to leave you with a bit more of a personal question. When I've looked on the Spotify and YouTube analytics for the episodes that we've released so far, we get a higher proportion of younger, like 18 to 24 year old people listening. So what's one piece of advice that you would give a graduate engineer? Let's say they've just come out of university, they're ready to go into the big world, and they want to go into the energy industry or into the manufacturing industry. What's one piece of advice that you would give to that person, let's say?
Well, I think that's an interesting question, because if I look at where I started and where I've headed, I could not have guessed that I'd be going down down this route. Um, what I'd say is just get stuck in. Um, you know, if you're interested in the energy industry or industrial energy industry for manufacturing, particularly, what I'd say is go and actually engage and get involved with the manufacturers. I worked in the paper sector to begin with, and the time I spent looking at processing, kicking pipes, and just absorbing what was going on in there is those are the sorts of skills that I think are missing, because if you can understand how things are made, produced, manufactured, break it down in your head, and then reform it as a part of a solution or an energy solution, that is quite a rare skill. It shouldn't be, but it is a rare skill, and usually you see opportunities where other people don't. So what I'd
Cool.
say is don't worry too much about what job title or industry you're heading into, as long as it's in the area, because you're going to build skills and you're going to make connections. So I'd say
Yeah.
start somewhere and get hands on.
Yeah. Yeah, that's really good advice.
Yeah,
Well, thank you so much, Ed. This has been a pleasure. Thanks for your time. I appreciate it. And I hope everyone listening has learned as much as I have in the last half an hour or so. So thank you very much,
yeah. Thank you for having me.
bro. And if anyone wants to pick your brains on, say, they've got their own industrial process and they want to get in touch about maybe they want to install a high temperature heat pump in their process, how should they get in touch with you?
um, Contact me directly through CR Plus or LinkedIn. Sure you can find me. We can have a quick look at your process and come to an answer pretty quickly, I think. So yeah, more than happy for you guys to reach out to me.
Brilliant. Thank you, Ed. All right. Cheers for your time. Bye now.
Cheers. Thank you. Bye bye.